Let's explore how to draw a charge diagram for our situation of the charged plastic pipe and the two spheres. When we start drawing a charge diagram, it's helpful to remember our tips. So we need to decide first, is the object charged or neutral? Let's begin with the plastic pipe. It was rubbed with the fur and acquired a negative charge. When we start drawing our charge diagrams, we begin by drawing the positive particles first. Drawing them throughout the object. Next, we add in the electrons. In this example, the pipe has a net negative charge. So I begin by drawing the neutral charge pairs, and now I'll give them a net negative charge. The exact number that I draw here doesn't really matter. So in this case, I've given the pipe a charge of -4 units. Now, let's look at the spheres. We have two spheres. One is an insulator, and the other is a conductor. Both of these are neutral objects. They are interacting with the plastic pipe because these two objects become polarized. So the electrons inside the objects shift position. To start our drawings, let's draw the positively charged particles for the two spheres. The exact number that we draw here isn't important, as long as we show them throughout the object. These spheres are neutral in charge, which means they have the same number of units of electrons as positively charged particles. Because our plastic pipe is negatively charged, the electrons in these two spheres get pushed away. They get repelled by the excess electrons here in the plastic pipe. So we will show these electrons pushed to the right-hand side of the positively charged particles. And this is equally the case for the foil sphere, the metal sphere, down here. Now, there is an important difference between how these two objects become polarized. The electrons of the insulating sphere are very tightly bound to the positively charged particles of their atom or molecule. So we show that by drawing the oval around each charge pair. The electrons in the conductor are not localized like the electrons in the insulator. They can move much more easily, and so as a group they shift over to the right, and they are not tightly bound to the positively charged particles. So we don't draw the ovals here. This shifting of electrons is slightly greater than this one, although we're talking about a very tiny amount on an atomic scale. And so that's the reason why we don't draw the ovals around polarized particles in a conductor. These electrons are not localized like these, and they shift a bit further over. This might seem like a very small distinction, it becomes very important later on.